Good afternoon, all. First of all, it's my pleasure to be here and to attend this conference. And I would like to thank all organizers of this important event. Our research is an analytical study on flexural behavior of one-way fiber foam concrete slab. Actually, this research was taken from a wall study entitled Experimental and Analytical Investigation of one-way fiber foam concrete slab reinforced with glass fiber grade with Dr. Rabab Al-Lawzi and Dr. Samih Qaqish. Let's start with one of the main conference topic, which is smart civil engineering or smart material. Actually, smart material are described as material that can achieve predictable, controlled, and variation in one or more of their properties. And due to advancement technology and continuous research regarding construction material, it has been possible for today's construction industry to improve lightweight foam concrete suitable for structural uses. Like one among those is development of lightweight foam concrete. Actually, foam concrete is classified as lightweight concrete. The practical density of this type of concrete is about from 300 to 1,900 kilogram per cubic meter based on ACI 87. Commercial demand for lightweight foam concrete has been strongly increased in recent years because its advantages over conventional concrete, like it's light in weight, like low density material, and economic and durable. Lightweight, or the unit weight of lightweight concrete, or let's start with conventional concrete. The unit weight of conventional concrete or normal concrete is about 2,200 to 2,400 kilogram per cubic meter, while when we talk about foam concrete, the density of this type of concrete way up to 1,900 kilogram per cubic meter. Foam concrete has air void content, has low density. So the main purpose of use lightweight foam concrete structurally is to reduce dead load. Foam concrete can be obtained by replacing some of solid material by air void. So depending on production method, foam concrete can be classified into three types. First of all is lightweight aggregate, and this by use lightweight aggregate. The second one is rated foam or gas concrete. This is by introduce a large number of void within the matrix. And finally, no fine concrete, which mean by omitting the fine aggregate from the mix, which mean large number of air bubbles are present. And now, why to use lightweight foam concrete structurally? Actually, foam concrete is a material consisting of sand, cement, water, and as well as foaming agent, which introduce air bubble within the concrete. Also in this study, we use PP fiber, polypropylene fiber, to enhance mechanical properties such as splitting tensile strength, compressive strength, and flexural strength. And the main use for structural lightweight foam concrete is to reduce dead load, which means result in reducing the size of element like slab, column, and other structural elements. So we can say foam concrete is a low density material, and also it has interesting properties like sound insulation, thermal insulation. Foam concrete has thermal conductivity about 0.66 watt per meter Kelvin, while conventional concrete at the density of 2,200 kilogram per cubic meter has a thermal conductivity about 1.66 watt per meter Kelvin. Also, it's high workability, flowable, and no compaction required, suitable everywhere and easy to produce. And the more interesting thing and fact about this type of concrete, foam concrete can provide a sufficient compressive strength if properly designed. By the way, this study based on a previous study we shared, Dr. Rabab Al-Lawzi, a research entitled Lightweight Foam Concrete Mixture for Structural Uses. That paper designed the optimum mix of formed concrete suitable for structural uses by cited trials. So the main purpose of use structural lightweight foam concrete structurally lead to reduce structural element size, less reinforcing steel, reduce concrete volume, functionally have a good thermal insulation, sound insulation, and fire resistance. Now, the question is why to use lightweight foam concrete in Jordan? Actually, in Jordan, foam concrete is a material known as an air filler material and insulation material, and use it as structural element has never been addressed. So this study recommends the use of lightweight foam concrete, especially in housing industry, also cause availability of raw material. Okay. We use a preform foam method to produce the foam concrete as final product. The common tests like plastic and dry density, workability, and compressive strength, splitting tensile strength, all are made. For reinforced foam concrete slab, actually 6 one-way foam concrete slab reinforced with glass fiber grid were tested to investigate the flexural capacity of this type of concrete with 2 different thicknesses. SG1 has 18 centimeter and SG2 has 20 centimeter. As we see here, the glass fiber grid was placed in tension zone, and why to use glass fiber grid as a reinforcement or alternative reinforcement, because actually glass fiber grid is strong, flexible, and thermally stable. We use unidirectional glass fiber grid in this study. Here, concrete placing of concrete and testing setup where all specimens were tested under pure bending moment during the mid-third of span during 4-point loading test. The results, let's focus on compressive strength. Compressive strength at 28 days is approximately 21 megapascal, and for splitting tensile strength is 20.4 megapascal. And for analytical study, actually an analytical investigation of PP fiber and a glass fiber grid contribution on the flexural capacity of this type of concrete were investigated. Also, the role of PP fiber on the stresses distribution investigated too. We use ACI code 440 and 545 to predict the flexural capacity of the slab reinforced with the glass fiber grid as following equation, where the tensile force of glass fiber grid is 2,000 Newton per every 5 centimeter. Actually, a weak bond between glass fiber grids and concrete or foam concrete was observed, and this led to a clear separation between the concrete cover and the rest of specimen as shown in this figure. Moreover, all slab with PP fiber didn't crack into 2 pieces because PP fiber hold the crack and hold 2 specimen to each other. Nominal moment and load capacity also calculated. The result of nominal moment were present in this table. For SG1, the nominal moment is 11.23 kilonewton per meter, while SG2 with more thickness, we have 20 centimeter. The nominal moment is 70.97 kilonewton per meter. Also, the deflection at the mid-span calculated based on ACI code 380 for SG1 is 4.5 millimeter, and the deflection of SG2 is 3 millimeter, and it makes sense. Analytical results and experimental results were compared, as we see in this table. We can conclude that there are a good agreement between analytical investigation and it's concluded. Conclusion, the low density less than 1,100 kilogram per cubic meter with compressive strength of about 21 megapascal was achieved by use foam concrete slab. The addition of PP fiber enhanced the mechanical property of this type of slab. All slab, I can say, are capable to carry the load of one-way fiber foam concrete slab, and they are weak bond between glass fiber grid and foam concrete slab. And finally, analytical investigation effectively predict the flexural capacity of one-way fiber foam concrete slab reinforced with glass fiber grid. And thank you.